Hello, welcome to Miss YY channel. Today we are going to discuss chapter 2, Atoms, Molecule and Ions. So atoms is a basic and the smallest unit in a matter, and we have molecule where there is more than one atoms combined together, and also ion where when there's a charge on the atom. Our learning outcomes will cover on how to describe protons, electrons and neutrons as subatomic particles in an atom, and how to define proton number, nucleon number and isotope, and also how to write the isotope notation. Let's start our chapter with a little bit history of the atomic model. So John Dalton was the first to propose an atomic theory where he discovered all matters is composed of extremely small particles called atoms. And further in 1897, J.J. Thomson proposed a plum-pudding model of atom where he discovered negatively charged electrons are evenly placed inside a positively charged mass. And further in 1911, Ernest Rutherford, which is the student of J.J. Thomson, has proposed the idea of the neutrally charged neutron particle in an atom. So later in 1913, Niels Bohr has proposed a Bohr's model of an atom, which he said that the model of an atom is similar to the model of the solar system, where the electron go around the nucleus like planet orbit around the sun. So you can see this is a Bohr's model. So in the nucleus, there's a protons and neutrons found in the nucleus, and there are electrons which can orbit around the nucleus. So Niels Bohr model has actually proved that J.J. Thomson and Ernest Rutherford theory wasn't so accurate. In an atom, there are three subatomic particles which are proton, neutron and electron. So in a neutral atom, the number of protons is equal to the number of electrons. The protons and neutrons of an atom are packed in an extremely small nucleus. Therefore, nucleus contains most of the atom's mass. The relative mass of an atom is almost the same as its nucleon number. So nucleon number is the total of proton plus neutron. The neutron number is sometimes used as an approximate relative mass in calculation. And the number of neutrons in an atom will determine the positive charge of the nucleus. And we have electrons which move rapidly around the nucleus of an atom, and the space where they occupy as they move define the volume of the atom, which is called the electrons cloud. Atoms is the smallest unit of a chemical element or compound. So this is a diagram of an atom, and there are electrons, neutrons and protons. So electrons is a subatomic particles that possess a unit negative charge and occupy the space around the atomic nucleus. So basically electrons will move around in the orbit and surround the nucleus. And we have proton, a subatomic particle found in the nucleus, and proton is positive charge. And neutron, which is uncharged, is also found in the nucleus with a mass slightly greater than proton. Okay, so let's look at the charge and the relative mass of the subatomic particles. So for proton, it is positive charge and the relative mass is 1 mu, and neutron there's no charge and the relative mass is about proton, which is also 1 mu, while for electron it is negative charge, but electron the mass is very little, which we can say is near to 0. So the relative mass of a proton is only contributed by the proton and also neutron. So that's why in the previous slide we can say that the relative mass of an atom can be taken from the nucleon number. Okay, by referring to the periodic table, let's try to find the number of protons and electrons of a few elements. So for example, hydrogen, there's 1 proton and also 1 electron. And oxygen, there are 8 protons and 8 electrons. And for sodium, there are 11 protons and 11 electrons. And argon, there are 18 protons and 18 electrons. And how about if for oxide ion, how many number of protons and electrons? So you can see there are 2 minus, okay, on the oxygen. So means that the oxygen has gained 2 electrons. And remember, when the atom become a charged ion, it's because of loss or gain of electrons. So the number of protons is always remain the same. So the number of protons is still 8, and the oxygen have gained 2 electrons because 2 minus, so the number of electrons is 10. So next we are going to find the number of protons and electrons for the ions. So for hydrogen ion, you have the H+. So plus means that the hydrogen atom has lost 1 electron. So the number of proton is still 1 and the number of electron will be 0. And sodium ion Na+, so sodium atom lost 1 electron. So number of proton is still the same, which is 11, and the number of electron will be 10. And for nitrogen neutral atoms, nitrogen has 7 protons. So if neutral means that the number of proton is same as the number of electron, which is 7. So if for nitrogen ion 3 minus, so nitrogen atom has gained 3 electrons. So the number of proton is still the same and the number of electron will be 10. Isotope can be defined as 2 or more atoms of the same element that have the same number of protons but different number of neutrons. So they have the same chemical properties but different physical properties. So let's look at the example of uranium-235 and the uranium-238. So 235 represent the nucleon number, which is the sum of number of protons and number of neutrons. So the 235 is a nucleon and also can be used as a relative mass number. So there are 2 types of uranium. We have the 2 types of uranium isotopes. So for 235, the proton number is 92, and 238, the proton number is also 92. So they're having the same number of protons, but the difference is the number of neutrons. So number of neutrons is nucleon minus proton. So it will be 143 for uranium-235 and 146 for uranium-238. Hydrogens has 3 naturally occurring isotopes known as deuterium, deuterium, and tritium. So you can see all the isotopes have the same number of protons, which is 1, and deuterium has 0 neutrons, deuterium have 1 neutrons, and tritium have 2 neutrons. So isotopes of an element have the same number of protons and charge of nucleus of the atoms, because the charge on the nucleus depends on the protons, and also number of electrons in a neutral atom, and it will have the same electronic configuration because of the same number of electrons and also the chemical properties. We can use isotope notation to represent 2 or more atoms of the same element, and this is an example of isotope notation where the X symbol here represent the chemical symbol of an element, and we have the A superscript here, which is known as nucleon number. So nucleon number is a sum of protons and neutrons in the nucleus. So nucleon number also known as mass number, and the Z subscript here is the number of protons in the nucleus. So Z also known as atomic number. If you like my videos, please like, share, and subscribe. Thank you. The proton number Z can tell us the nuclear charge, which means the charge of a nucleus in an atom, and also can tell us the number of electrons if it is a neutral atom. So the number of protons is equal to the number of electrons in a neutral atom, And then when the number of protons is more than the number of electrons, so we will get a positively charged ion, cation, because the atom has lost electrons. And when the number of protons is less than the number of electrons, the atom will become negatively charged ion, which is an ion. It means that the atom has gained electrons. So let's look at this example. The right superscript shows that the total charge on the ion is 2+, and the right subscript shows that the ion is formed from 2 mercury atoms. And the left superscript shows the nucleon number of the mercury, which is 202, and the left subscript shows that the proton number is 80. So based on the information, we can find the number of neutron, which is 202 minus 80 is equal to 122. Now let's look at the example questions. An atom B has 1 proton, 2 neutrons and 0 electron. Write the isotope notation. So based on this information, 1 proton, 2 neutrons and 0 electrons, so you can see the atom B has lost 1 electron. So the chemical symbol for atom B will be B+, because it has become a positively charged ion. And many students did the mistake by just putting the chemical symbol as B. And the nucleon number is proton plus neutron, which is equal to 3, and the proton number is 1. So be careful when you are writing the chemical symbol. You need to be aware whether is it a neutral atoms or a positively charged or negatively charged ion. Let's look at the next example questions. Based on the isotope notation, state the number of protons and electrons and neutrons. So this isotope notation tells us that it is a cobalt element, and there's a 3+ at the symbol. This tells us that the cobalt atoms has lost 3 electrons. So the proton number for cobalt is 27. So after losing 3 electrons, it becomes 3+, so the number of electrons will be 24. And we have the nucleon number, which is 59. So to find the number of neutrons, 59 minus 27, we can get the number of neutrons is equal to 32.